Yeah, the most amazing part, calculations. We are going to begin our chemical equilibrium calculations. You are beginning with esterification. So let's first look at those calculations that involve the formation of an ester, okay, from ethanoic acid and ethanol. It's not mandatory that you must form ether ethanoate. Esters can be different, okay? Can form propyl ethanol, you can form different esters, but I'm just considering that reaction where we are having an alcohol with a carboxylic acid to come up with an ester, and have decided to begin with ethanoic acid and ethanol being treated to bring ether ethanoate. Let's interpret this question and we see how we can come about, how we can go about it, okay? When 60 grams of ethanoic acid, by having the mass of ethanoic acid, we can get the number of moles. Remember, we shall be guided by the other experiments that we did. We shall be guided by that experiment to see how we can calculate that value of Kc. So we're having 60 grams of ethanoic acid heated with 46 grams of ethanol. So here we can get moles of the reacted substances until equilibrium was reached. 12 grams of water and 58.7 grams of ethanoate were formed. Calculate the equilibrium constant Kc. So we need to first get moles. So I will say part 1, molar mass of ethanoic acid. This is carbons there 2 times 12 plus oxygens there 2 times 16, hydrogens there 4 times 1. So this one gives us 60 grams. Still can get molar mass of ethanol. Carbons there are 2, so 12 times 2 plus hydrogens there are 6, so it will be 6 times 1. Oxygen is 1, so 1 times 16 is going to give us 46 grams. So having gotten this, we can get moles, converting a mass to moles. So it is equal to the molecular mass over the relative atomic mass. So the mass, 60 over the molecular mass or the molar mass, which is 60. So this gives 1.0 moles. Then we can also get, these are moles of ethanoic acid. Then we also get moles of ethanol. They will be equaling to the mass of ethanol, which is 46, divided by the molar mass, which is also 46, giving us 1.0 moles. Still, we can get moles of water and moles of ethyl ethanoate. So molar mass of water is 1 times 2 plus 16, which gives 18 grams. So we can get moles of water. Moles of water will be equaling to the mass of water, which is 12. So we shall get 12. We divide by the molecular mass 18. So this gives 0.667 moles. Then also we get molar mass of ethyl ethanoate. Of ethyl ethanoate, that is CH3COO CH3. So the molar mass of ethyl ethanoate, we shall come up with 4 carbons times 12 plus 8 hydrogens times 1, then plus 2 oxygens times 16. This gives you 88 grams. Then we can get moles of ethyl ethanoate. Moles of ethyl ethanoate will be equaling to mass, which is 58.7, over the molar mass 88, which will give us 0.66 also 7. Now from here, after getting the moles, how did I get moles? I've been given masses of each and everything. So with masses, I can easily compute the number of moles. Now, after this, I am going to write the equation where I'm going to generate the information as we did in the experiment. So I have ethanoic acid, liquid plus ethanol, liquid we shall form ether-ethanoate, liquid and water. So initial moles. Initially, we have moles of ethanoic acid, 1.0, 1.0, but we do not have moles of ether-ethanoate and moles of water. Initially, we don't have moles of the products. Then we need moles that reacted. Moles reacted or formed. Moles of ethanoic acid reacted. Yeah, so the moles reacted are going to be equal to 0.667. Okay, because if the moles formed are these and the reaction ratio is 1 to 1 to 1, so they are the same throughout. 0.667, 0.667, 0.667. Then if I am to get moles at equilibrium, right? Moles at equilibrium, we shall subtract here. So it will be 1 minus 0.667, 1 minus 0.667. These ones will keep the same. So this is going to give us 0.33, 0. And this will keep the same. But our case C is given by the concentration of the products, ethyl-ethanoate, times the concentration of water over concentration of, I'm assuming that that the volume maybe is 1 liter because we are not given any specification of the volume. So this is concentration of ethanoic acid and the concentration of ethanol. If we have to substitute direct, this one will give 0.667 squared since they are the same over this one is 0.333 squared since they are the same. Then our case C is going to be 4.01. 4.01. That is our value. Okay, that is our value of the case C. Then part 2 wants us to get the mass of ethyl-ethanoate. Remember, since this is a constant, we shall check on this value and we shall use it for the rest of the calculation. It won't change, it will keep the way it is. So now the Kc value, we've already gotten it. Now they want the mass of ethyl ethanoate that would be formed under the same conditions if 90 grams of ethanoic acid and 92 grams of ethanol were formed, rather were heated. So for this case, we need to get new moles of ethanoic acid and new moles of ethanol. Let's see, Roman 2. It means that for moles of ethanol, sorry, let me begin with ethanoic acid. To be according to the mass of ethanoic acid, which is 90, we divide by the molar mass, which is 60. This is 1.5 moles. Then also get moles of ethanol. Moles of ethanol would be equaling to the new mass, 92, out of molar mass, 46. So that is 2.0 moles. Everything has changed now. But they have not given us the masses of the other substances that were formed. They didn't give us mass of water. They haven't given us mass of ethyl ethanoate. Instead, they want us to get the mass of ethyl ethanoate. So if we are to generate from equation again, this is ethanoic acid plus ethanol to form ethyl ethanoate and water. The initial moles have now changed, whereby ethanoic acid we are having 1.5 and ethanol we are having 2.0, but here we got no moles. Then moles reacted or formed, I'm going to assume that moles of ethanoate formed is X. Since the mole ratio is 1 to 1 to 1, everything is going to be X. However, we are going to see some other different examples where we have to be too careful. Okay, even here you have to be too careful, but this is very direct a bit. Now, then we get moles at equilibrium. Moles at equilibrium, we subtract. So here we shall have initial moles minus moles used, initial moles minus moles used, and this will keep X, because if you have 0 minus X, you keep negative X, but we can't have moles as negative. So after that, we know that our Kc is the concentration of ethyl ethanoate times the concentration of water over the concentration of ethanoic acid times the concentration of ethanol. But we already have the Kc as 4.01 equaling to, now, these are X. We use moles at equilibrium, so it will be X squared over 1.5 minus X times 2.0 minus X. Now here we shall employ our math. So our math is such that 4.01 1.5 minus X 2.0 minus X is equals to X squared. So simplifying this, we shall come up with 3.01 x squared minus 14.035x plus 12.03 is 0. How? First open this bracket, first expand this. Then after you multiply 4.01, then bring x squared this way. So here you have to use, we are looking for the value of x. X is minus b plus or minus the square root of b squared minus 4ac. Everything is over 2a. So when you substitute, you get the value of x as negative b, which is 14.035 plus or minus the square root of b squared, which is 14.035 squared minus 4 times a, which is 3.01 times c, which is 12.03. Then everything is over 2 times a, so it will be 2 times 3.01. So here we shall get a value of x. Here I don't have a negative because we say that it is negative b, and yet here is already negative. So our x is going to be, here you can press on your calculator, but after showing me this substitution, so you'll have your x as 3.48 or 1.14. So since they were moles, okay, so it means that x can be 3.48 moles or 1.14 moles. But you can't really, x cannot be this, x can't be 3.48, since the number of reacted moles cannot be greater than initial moles. That's why we subtract. So they can't go, they shouldn't go beyond 1.5. So that's why we shall end up taking that. So discard, I cannot, and I said discard 3.48 for it is greater than, initial moles. For it is greater than initial moles, and therefore we shall say that x is 1.14. So moles of ethyl ethanoate is equals to 1.14 moles. But they need the mass. So let me complete it from here. Since they need the mass, it means that I have to look for the molar mass. If they need mass, you have to go ahead and look for the molar mass. So molar mass of ethyl ethanoate we had already seen that it is in 88 grams. But when we say molar mass, we are trying to talk about the mass in 1 mole of a substance, meaning that 1 mole of ethyl ethanoate weighs 88. So 1 mole of ethyl ethanoate weighs 88 grams. So if 1 mole can weigh 88 grams, what about 1.14 moles? So 1.14 moles will weigh 88 times 1.14 grams. So the mass of ethyl ethanoate will be 100.32 grams. And that is how you would really get the answer. That is how you would really get the answer. Okay. Let's do some other example under this section of esterification. So example number 2, 1 mole of ethanoic acid was reacted with 5 moles of ethanol in a sealed glass tube left in water bath for some hours at 60 degrees Celsius. The tube was then broken, okay, in cold water. The tube was then broken in cold water, and the resultant solution required 289 cubic centimeters of 0.2 molar sodium hydroxide solution. For complete neutralization. Calculate the equilibrium constant Kc. Calculate the equilibrium constant Kc for the reaction. Now we need to first know the essence of bringing in sodium hydroxide. It means that if sodium hydroxide is a standard solution, why? Because its concentration has been given and you have its volume. So you can get the moles of sodium hydroxide that reacted. And since sodium hydroxide from the experiment, we saw that it reacts with ethanoic acid forms sodium ethanoate. Therefore, we can get the moles of ethanoic acid also. And after getting the moles of ethanoic acid at equilibrium, we can push our calculation very, very smoothly. So the whole thing will begin with getting moles of sodium hydroxide. So 1,000 cubic centimeters of sodium hydroxide contain 0.2 moles because this is molar solution. It means that those moles are in 1,000 cubic centimeters. So if 1,000 can contain 0.2 moles, what about 289? .2. So this one will give us 0.0578 moles of sodium hydroxide. After getting moles of sodium hydroxide, I can get moles of ethanoic acid because ethanoic acid, I know that it reacts with the sodium hydroxide, right, to form sodium ethanoate. And water. So it means that since the reaction ratio is 1:1, then from the equation, we can really see that moles of ethanoic acid are also going to be 0.0578. But these are moles at equilibrium. These are moles at equilibrium, moles of ethanoic acid at equilibrium, because you have already reacted with sodium hydroxide. Now, after having gotten this information, that is when we can reflect back to our equation of esterification. Ethanoic acid liquid plus ethanol liquid to form ethyl ethanoate liquid plus water liquid. So having gotten this initial moles, ethanoic acid, they say 1 mole of ethanoic acid, 1 mole. So we have 1, just 1. Then moles of ethanol, they said 5, so 5. But initially we have not formed ethyl ethanoate, we've not formed water. Then now it is here that we go to moles reacted or formed. The moles reacted or formed. Now, the fact that because they are saying that 1 mole of ethanoic acid was reacted with 5 moles of ethanol. So now, if 1 mole was present, so they need the equilibrium constant Kc. All right. Now, the moles that reacted, it will be 1 mole here minus 0.0578, which would give 0.9422. And since the reaction ratio is 1 to 1 to 1, it will be 0.9422, 0.9422, 0.9422. Then at equilibrium or equilibrium moles, the moles at equilibrium would be, of course, this one, of course, we said that the moles of ethanoic acid we form here are the moles at equilibrium, so it will be 0.0578. And for ethanol, it would be initial moles, which is 5 minus 0.9422. Then this one will keep the same 0.9422, 0.9422. And when you subtract this, you'll get 4.0578. But they need the value of Kc. So Kc would be the concentration of ethyl ethanoate times the concentration of water over concentration of ethanoic acid times then the concentration of ethanol. Ethanol, CH2OH. So these ones are 0.9422 squared over ethanoic acid 0.0578 times 4.0578. And this one will give the value of Kc as 3.79. We shall do as many examples as possible, over 20 examples. By the time we look at all the equilibria, we shall have understood the concept. So under esterification, let's do the final question, but in other equilibria, we are going to look at too many of them. So let's look at example 3. A 10.0 cubic centimeter mixture initially contained 0.0515 moles of ethanol, 0.0525 moles of ethanoic acid, and 0.0314 moles of an ester, 0.0167 moles of water, and 0.001 moles of hydrochloric acid. If at equilibrium, the moles of ethanoic acid found were 0.0255, capture the equilibrium constant. Capture the equilibrium constant for the reaction. Well, one may be like now, because for you, the equation which you know is CH3, COOH, plus ethanol to form CH3 and water. So one may ask, what is the role of hydrochloric acid in this reaction? Simply, it is to catalyze. It acts as a catalyst in this case. So initial moles, in other words, we are going to neglect it. Initial moles of ethanoic acid, they were ethanoic acid was 0.0525. Ethanol was 0.0515. Ethyl ethanoate, which is an ester, 0.0314, while water is 0.0167 from the question. Because initially they gave us the moles initially. Now, moles reacted or formed moles reacted or formed. Since they told me that the moles of ethanoic acid at equilibrium was found to be this, so to get moles that reacted here, I'll get 0.0525 minus the moles which I have at equilibrium, which is 0.0255. So this one will give me 0.027. And since throughout the mole reaction ratio is 1 to 1 to 1 to 1, it means that also here I have 0.027, 0.027, 0.027. Now, to get moles at equilibrium, I will be having 0.02 moles at equilibrium. For this, we are found to be this, so we rewrite that 0.0255. Then moles at equilibrium for ethanol, it will be 0.05 minus this. And it will be 0.0245. Why am I not subtracting here? Because they have already told me that moles of ethanoic acid at equilibrium we are found to be this. So I rewrite it. But for this case of ethanol, to get the ones of equilibrium, we have to subtract this and this so that we get the ones at equilibrium. Then now for this case, to get moles of equilibrium, if you have initial moles and then you formed this, at equilibrium we have a total of these moles. So it will be 0.0314 plus 0.027. And this one will give you, this will give you 0.0584. So this is 0.0167 plus 0.027. This one will give you 0.0437. Now to get the Kc, it will be the concentration of an ester times the concentration of water over concentration of ethanoic acid times concentration of ethanol. So you substitute direct. For ester, we shall have 0.0584 times water 0.0437 over ethanoic acid 0.0255 times ethanol 0.0245. This will give you the value of Kc as 4.08. That is all for today. And in our third video, actually in our fourth lesson, we are going to be looking at the reactions involving hydrogen, hydrogen iodide, iodine, like that. What I do believe we shall record like more 4 lessons and we bring this topic to an end, because now it is just a series of enjoyment full of calculations only. See you in our fourth lesson.